All right, so we are going to work through this problem. It's going to take a while. We're going to do it by hand, and then after this, if you don't want to do it by hand, I'll show you how to do it on the calculator, okay? But you can do it by hand every time if you want. Okay, so we have a dice game. Let's make a quick little table. Doesn't need to be fancy. Bless you. All right, so the first thing I'm going to write down is just the dice value. All right, we have, you could roll a 1, 2, or a 3. You could roll a 4 or a 5. Or you could roll a 6 and get different point allocations. So the next thing I'm going to do is the points. How many points do you get if you roll the dice and you get a 1, 2, or 3? 0. You get 0 points. What about if you roll a 4 or a 5? You get 5 points. And if you roll a 6, you get 50 points. Nice. That's a huge difference, right? Now, the last row, I'm going to label as the probability of those happening. Okay? So what is the likelihood that I'm going to get 0 points? We want to, if you're going to say 50, you need to say percent, right? Because you don't want to confuse people with points. I'm just going to do it right now as a fraction. You can write 1 over 2. You could write 0.5, 50%, whatever you want. I want to just show everyone's brain and all my subscribers that are going to watch this later that I'm doing 3 out of 6 because there are 6 possible numbers and there are 3 options out of those 6. You know, when you're going to make fun of me, just wait until you're out of the classroom, okay? Okay. Now, for 5 points, you're rolling a 4 or a 5, you can see that there's 2 possibilities out of 6. Or you could write 1/3, or 0.33 repeating, or 33%. And then finally, the last one is going to be 1/6. Okay, now what's really nice about this is in your homework, when you do number 1, they give you the table. Okay, and on the quiz on Thursday, I'm going to give you the table. You don't have to make it. All right, you're welcome. That's the least I could do, right? Now, the first thing I want to find is the expected value or mean. So when somebody walks up to play this game, that's walking apparently. When someone walks up to play this game, I want to be able to tell them, here's what I expect you to get when you play this game, the number of points. Okay, so here we go. You can write a capital E and a capital X here. This is the expected value for our random variable x. You could also write mu. Both are acceptable. Do you need to write both? No. So just pick one. Or you can write both. Cool, I don't care if you write both. But they're the same thing. So if you see E of x, the expected value of random variable x, or you see mu, you know they're finding the expected value or the mean. All right, and here's how you do it. We're going to take the point value of 0. Write it down. What is the likelihood I get 0 points when I play the game? 3 out of 6. So I'm going to write down times 3/6. Plus, what's the other point value coming next? 5 times the likelihood of getting 5 points, which is 2/6. Let's go a little faster. Plus the last one, 50 times 1/6. So you take your calculator out if you have it, or you can get one from the back, and you should be able to find your expected value. If I do some quick mental math, I see that this one is 0, right? That one goes away. This one is 10/6, and this one is 50/6. If you add those together, you get 60/6, which is 10 points. Yes. Confirm. Excellent. Do you need a calculator, Kiara? There you go. It's all good, right? It's not laziness. I'm just telling you that you can do this mentally. You don't have to. You have a calculator. Okay, my bad, sir. Any questions on how to find the expected value? So what you just did, and you don't have to look back at this, but what you just did is you use this formula. Okay? You took all of the possible values. This was 0 5, and 50, times each of their probabilities, which was 3/6, 2/6, and 1/6. You multiply the respective ones, and you add them together. That's all you did. You just used that formula without even knowing it. Okay? It's right here. I'm sorry. So sorry. There you go. Okay. Now's the fun part. Standard deviation. Okay? So, I'm going to do a couple little dotted lines here. All right? Now, ultimately, we're going to end up finding the variance first. All right? But I'm going to write standard deviation just to let someone reading this or people watching that I'm finding the standard deviation. Okay, so here's how you do it. Okay, what's the first point value I could get? 0. You're going to write 0 minus the mean. So how far away is 0 from the mean? That's what we're doing. So 0 minus 10, right? Because 10 is the mean. Now think back to when we did this, how was it last semester? Earlier in the semester, right? What do we have to do to make sure that we don't cancel things out as we start adding? What do we have to do here to make sure we don't cancel things out? What am I going to put right there? Close. Square. Because if you square it, then it becomes positive for sure. Okay? Now, because this is a probability model for a random variable that has different probabilities for these options of happening, we're not going to move to the next one yet because is the 0 always going to happen? No. It has what likelihood of happening? So you write times 3/6 plus the next possible value I could get on the dice game is 5. So 5 minus 10 squared times 2/6. Or 1/3 is fine. And then finally the last one plus 50 minus 10 squared times 1/6. Okay? How did I get 10? Are you like, why am I using 10? Or how did I get 10? I'm using 10 because when you find the standard deviation, it's always the average distance of your values to the mean. So we want to know how far away, on average, our data values are from the average, from the expected value, the mean. All right, so the formula up here, what I'm using, is these point values, the 0, 5, and 50, minus 10, our mu, squared times their probabilities of happening. The mean is the expected value. It means when someone walks up, Catherine, you walk up saying, I want to play the dice game. I would say, okay, Catherine, I expect, on average, that you'll get 10 points. And we'll talk later about how that can be confusing. Okay. Everybody good with the work? All right, who did it? Who did it? You did it? Okay, so this is actually called the variance. All right? This is called the variance, what you just found. All right, say what you found. 325. I want someone to confirm that. So someone needs to start punching in some buttons. Guillermo, you confirming? Wait, Diego confirm? 325? 325. Now, what are the units here? Do you know what the units I'm going to write here for the variance? Not points. Ooh, so let's put those together. Squared points. That's so cute. Okay? Squared points. But do I want squared points? No, I just want points. So to find the standard deviation, we take the square root of that. So the square root of 325. It is a lot, which is why you're going to really enjoy this when I show you how to do it by calculator. What is it? Don't guess. You're sitting with a calculator right now. Can you hit the, if you get a square root, hit the button above the enter key, and it'll make it a decimal. Hit the button above the enter key. Yep. Boom. 0.2? You know? That's why they pay me the big bucks, David. Okay. Now, I want to talk a little bit about what we just calculated. Okay? I already mentioned how if a student or anyone comes up and says they want to play this game, I'm going to tell them that on average, I expect them to roll the dice and get 10 points. You should immediately be confused by that, because is there even a possibility of them getting 10 points? No. So one of the things that really messes with students' minds is that the expected value can be a number that's not even possible to actually get. Because over time, if I play it 100 times, 1,000 times, 1,000,000 times, I'm expecting 10 points.
But that wouldn't increase or like as many times as you roll.
No, because remember, I could get 0, and 0, and 0, and 0, and 0. I could, right? But if I play 100 times, I expect, well, you would take the average of that. All right, sorry, I should have had a clear jar. My bad. My bad. So if you played 1,000,000 times and divided by 1,000,000 your total, it would be 10. Yeah, I'd expect it to be 10. My bad, I'm so sorry. I thought I'd said that clearly. I did not. Everybody good with the expected value? Okay, now, the standard deviation of 18 points, that's fairly high, and you should, some of you, I think it was David maybe, somebody noticed there was a big jump here. That big jump from 5 to 50 is what's driving this massive variability. Okay, so 18 points is a fairly high standard deviation, and that makes sense because we have such a big point value for that rolling of the 6. Okay, any questions on finding this stuff?
That's it.
That's it for the first slide. That's it. Let's keep going. Okay, imagine now the points are doubled. You ready for this? Another table.
Can't you just double it?
Well, let's see if that's actually true. I get students every day like, well, let's just double it. Well, do you know why that's okay? All right, so the first one we had was dice. We had 1, 2, and 3, 4 or 5, and then 6. But now for the points section, the points row, it's going to be 0, 10, and 100. 0, 10, and 100. And I'm going to show you how to do this one by hand or by calculator. Well, I mean, it will be with your hand, but we're using a calculator. I misspoke, Bianca, okay? I'm so sorry. Now, for the probability, that doesn't change. Was it Daisy?
Yeah.
My bad, Bianca. That's my bad. Daisy! Hey! Well, then focus. Bianca! All right. I don't know what I'm doing. It's been a long day. Okay. So, all you should notice is that we changed the point value. So take out your calculator. Remember to take it out. Turn it on. On. I want you to click data. It does. Cool. Yeah, right? Yeah. You see that you can't really do much with that. Okay. So I want you to type in. You see how if you hit data it says L1? So I want you to type in 0. And hit enter. And then type in 10.
For the same one?
Nope, next one. I mean the same column, yes. And then hit enter, and then type in 100. And hit enter. Make sure you hit enter at the end. So you have in column L1, you have list 1, 0, 10, and 100. Okay? Go to list 2. Go over to list 2. Let's see if it does this. I don't know if it does. In list 2, in the first slot, click N over D. Does it do that? Does it give you the slash? Okay, so do this. Type the number first. Type 3, N over D, 6. And hit enter. You see why I want it to be true, because if you type in rounded, it won't be perfectly right. So, I want it right. Did you guys hit enter? So it changed it to 1/2. So now do the next one, which is 2, and then hit the button, N over D, and then 6. It'll change it to 1/3. And finally, hit enter. 1, N over D, 6, enter. All right, does everyone have that in there? List 1 and list 2. If you don't have it, I have it right here. So if you raise your hand if you don't have it, I can show you what it should look like. Anyone else need to see what it looks like? Right? Okay. Okay, so now the fun part. Okay, so I want you to hit second data, which is stat. Okay, so second data, which is stat. Now let's see where it says second data, and you should have something that says stats, and then one variable statistics or two variable statistics. Okay, you're going to click number one, which is one variable, one var stats. Okay, enter. Now, do you see how it's blinking on data L1? That one's fine. So scroll down. You see where it says FRQ? That's not a free response question. That's frequency. But guys, the frequency of 0, 10, and 100 is not even, right? It's 3, 6, 2, 6, 1, 6, which we put where? In list 2. So you're going to scroll over for frequency, and where it's blinking on L2, hit enter. So now you've got it where the data is in list 1 and the frequency is list 2, and you hit count.
Calcium.
Okay, now what?
Well, do you see number 2 where it says X bar?
Yes.
That is our mean. Is going to be, I guess I should write 2 because we're doubling it, is going to be 20 points. No, you would just put mu.
Oh.
That's a good question, right? Or you could have made a really good joke there. Mu 2? Yeah. I would have enjoyed it, but it's passed. Okay, now the standard deviation of this new one where we double the points, if you scroll down, you'll see SX says error. So it's not that. Do you see number 4 where it has sigma of the variable? It says 36.06 points. And what do you notice about the standard deviations?
They're 2 times.
It's doubled as well. All right? So what we just proved is that if you want to double or times 3 or times 4, or if you want to divide half something, right, divide, you can just double the numbers. Okay? But, guys, that doesn't work. That works for multiplying. It doesn't work for adding and subtracting. Okay? If you think back to, we talked about this, I think it was in chapter 5, 4 or 5, a long time ago. Okay? If you start using adding and subtracting, your center will change, right? Your mu will change, but your standard deviation will not change. So if they had said, I want to take these point values and add 30 to them, okay, the only thing that would have changed would have been your center. All right? Yes,
So
try this.
if you're doing the calculator,
Mhm.
you're gonna find the standard deviation.
That one, yeah. Number 4, yep.
Always.
Always. All right, let's go to the next box. We're close. 2 more to go. 2 more to go. Okay. Now it says to imagine playing the game twice. Okay? So this is not the points are doubled. We're going back to the original problem that the points are 0, David? 0, 5, and 50. Back to the original, 0, 5, and 50. Okay? So now I need to find the expected value of playing it the first time and then playing it again. Okay? Now here's what's something cool about this. When you add random variables like this, because that's what we're doing, we're adding these 2 random variables, you can just add the means. So we're going to take 10 points and add another 10 points to get 20 points. I'm scared. Now you'll notice when I'm writing my notation, you might not have noticed, but if you look here, you'll notice I'm not writing this as 2x because it's different, right? Playing the game twice is different than doubling the points for one play. Okay? So I know you're thinking back to algebra, you'd put these together up here, but don't do that in statistics. Right? Leave that notation separate. Okay, now here's the fun part. The standard deviation. I wish I could tell you that you just add them. But if you remember that thing you wrote on your notes with the 6 exclamation points, We need to add the variances. Okay, but luckily we've already calculated it, right? Diego confirmed Charlize with the very beginning, where what was our variance in this first problem? It was 325, right? The variance was 325 of the original point values. So what I'm going to do is I'm going to add the variances. So I'm going to add 325 plus 325 to get, I heard David say it, bless you, 650. But that is the variance of adding these together. So that's in squared points. So Jarvis, you're right. We have to take the square root of 650.
25.5.
Let's go one more.
Oh, this is 25.495. So
495, so 50. Thank you, sir. Okay, now once you finish writing this, I want your brain to look back to the slide above this. The standard deviation in the original problem was 18 about, right? And we just played the game twice. And what happened to the variance? Excuse me, the standard deviation. What happened to the standard deviation? It went up. But did it go up by double? No. Okay? So even though we are increasing the variability here, the standard deviation went up, I get students every time that want to add 18 and 18. All right? So that's why you're going to tattoo right on your right bicep, variances, add. Variances, add. Okay? Only of those of you that are 18. Not in your forehead. I wouldn't recommend that.
It comes after a year.
Okay, I'm going to do the next one. One more. One more. And then we'll play Greedy Pig. One more. Okay. Now it says you and a friend are playing the game. What are the expected value and the standard deviation of the difference? Of the difference. So what am I doing here? You're subtracting. So I'm finding the expected value of subtracting. I'm going to use y because it's not you. It's a friend. All right. But what is your friend's expected value? You actually, it's the same, right? Unless your friend's playing a different game, which you should just call them out. That's cheating, right? If you're playing the same game, then you both have an expected value of 10 points. And we're just going to subtract that. So what do I expect the difference in our points to be? 0 points. It'd be 0. Okay? Now here's where it gets crazy. Okay? Here's where it gets super kooky. Okay? Okay, cool. We are doing the difference, which is subtraction. But to find the standard deviation of this, we're still going to add the variances. I know. It's going to be the same answer. The standard deviation of the difference in our point values is still 25.50 points. Now, I'm going to do my best to try to explain this. Okay? I will do my best, once everyone's written this down, to try to give you an example to explain why, even when you subtract, you're actually still increasing the variability, the unknown factors. Okay, you ready? Okay, so you should put your pen or pencil down. I'm about to explain, Jarvis, why we still add variances, even though we're subtracting with this problem. So we just subtracted to find the expected value, right, Jarvis? We subtracted. But when we did the variances, we still added. Right? We still added them. Okay, so here we go. Let me just pen or pencil down. Okay, so at Chick-fil-A, they have like a poster. All right, some of the restaurants, I've been to a few. At Chick-fil-A, they have posters that shows how they make their lemonade. Okay? And it says lemons, sugar, and water. All right? That's not lemonade, but that's okay. It's all good. Doesn't matter. I could have used tea. I should have done that. It would have been better. Man, I could go back in time. If I could turn back time. I can't.
Oh, you can do a hot.
Oh, yeah. Arnold Palmer.
Stop getting me off track. Okay, I should have just stopped. No. Let's imagine we're making lemonade, okay? Does everyone hold your thing up?
Imagine it's yellow.
Okay, let's say in there is 32 ounces. Okay? It's full. All right? I don't know for sure because I didn't measure it, but I think it's 32 ounces. Okay? I don't know for sure. I pour myself a glass. All right? I'm holding a glass. I pour myself a glass. It's a 12-ounce glass, but I don't fill it all the way up. So I just think it's about 12 ounces. It's about 12 ounces. Okay? So if you subtract those, you get 20 ounces. But here's the crazy part. Okay? I'm going to try to do my best here. Okay? At 32 ounces, how sure of the 32 were we? Fairly sure, right? All the way to the top? Yeah, that's probably 32, close. After I pour out the 12-ounce glass, which I'm less sure about the 12, how sure am I about the 20 ounces? Not as sure as I was at 32. So I've actually subtracted, but I've increased my level of variability. So I'm even less sure, so I've increased my variability, which is why even when you subtract, you still add variances. You add variabilities. Yeah?
Like for cups, you know how they say certain ounces?
Yeah.
Like, do they measure it to the top?
No,
Like,
to the
full
line.
cup?
What am I, a cup maker? I don't
To
know.
the line.
In the cup?
All right.
Yeah, there's a cup.
Bro, I wish